Hudson Bay, vast, icy, and silent, seems untouched by time. But beneath its frozen surface, Earth is whispering a secret. This is not just a tranquil bay, it's the site of a profound mystery, written in the very pull of gravity. Here, things weigh less, not by much, but enough to set off alarm bells for scientists. The gravity over Hudson Bay is weaker than anywhere else in North America. Why? The answer lies deep beneath the surface, at the boundary between the crust and the mantle. Imagine a giant invisible dent in the Earth, a gravitational void, hinting at a scar from a cataclysmic event long ago. But this isn't just ancient history. The anomaly may be a sign of something still unfolding deep within our planet. Could this hidden force be connected to other powerful geological phenomena across the continent? The story of Hudson Bay is not just about the past. It's about the living, breathing, and sometimes violent present of our planet. Scientists have spent decades chasing this puzzle, drawn by the faint pull of gravity and the echoes of seismic waves. The clues point to a force of unimaginable scale, a geological giant hiding in plain sight. This is a detective story on a planetary scale, with Hudson Bay as the first clue. The mystery begins with a simple observation. The ground here is not what it seems. The gravitational pull is weaker, and the reason why has drawn geologists and physicists into a decades-long quest. What lies beneath Hudson Bay may hold the key to understanding the forces that shape our world. And as we'll see, this quiet bay is just the beginning of a much larger story. Why focus on this remote icy sea? Because Hudson Bay is one of the most significant gravity anomalies on Earth. For decades, scientists have measured a strange gravitational deficit here, one that can't be explained by surface features alone. The first theory pointed to the last ice age. The Laurentide ice sheet, miles thick, pressed the crust down. When it melted, the land began to rebound, a process still happening today. But as measurements improved, it became clear post-glacial rebound explains only part of the anomaly. Something deeper is at work. The search for answers led scientists to the mantle, the vast layer of superheated rock beneath the crust. Here, they found evidence of a powerful downward current, a mantle downwelling, pulling the tectonic plate down and creating a deep depression. Imagine a pot of boiling water. Hot material rises, cools, and sinks. The mantle behaves similarly, but on a scale of millions of years. The Hudson Bay anomaly is not just a story about ice, it's a story about fire, about the dynamic forces shaping our continent from below. This realization shifted the focus of research from the crust to the deep Earth. Scientists now believe that a massive, slow-motion waterfall of mantle rock is dragging the North American plate downward. This process creates a gravitational void, a region where the planet's mass is mysteriously lower than it should be. The anomaly is a sign of a living, dynamic Earth, one whose secrets are still being uncovered. Hudson Bay offers a unique window into these hidden processes. Understanding this anomaly means understanding the fundamental forces that govern our world, and it may connect to other, even more dramatic geological features across North America. The mystery deepens as we look beyond the bay. Using the GRACE satellites, scientists mapped Earth's gravity with unprecedented detail. Over Hudson Bay, they found a vast, circular region of significantly lower gravity, a ghost in the planetary machine. Stand on a scale here, and you'd weigh a tiny bit less than in New York or Toronto. The reason? There's less dense rock beneath you. Early surveys hinted at this anomaly, but GRACE revealed its true size, hundreds of miles across. The data showed that only part of the effect is due to post-glacial rebound. The rest comes from deep within the mantle. The leading theory, a colossal downwelling of cooler, denser mantle material, is dragging the crust down. This process warps the continent and leaves a signature in the gravity field, detectable from space. The Hudson Bay anomaly is one of the most prominent features on Earth's gravity map, a clear sign that something extraordinary is happening below. And it's not just a local curiosity, it's a clue to the planet's deep dynamic processes. Gravity anomalies are windows into the planet's hidden architecture. A negative anomaly, like Hudson Bay's, signals a mass deficit, less dense rock or a thinner crust. By mapping these anomalies, scientists create a geological X-ray, revealing structures far beyond our reach. Gravity maps help us understand plate tectonics, ancient collisions, and even hidden magma chambers. The Hudson Bay anomaly stands out, a headline feature demanding explanation. Its scale suggests continent-wide forces at work, not just a local quirk. The idea that a massive downwelling is actively pulling down a huge chunk of North America is profound. It means our tectonic plate is being tugged and warped by the churning mantle below. Could this force be influencing other major geological features across the continent? The story now turns from the icy north to a place of fire, Yellowstone. The connection between these distant regions may be the key to understanding North America's deepest secrets. To see the bigger picture, compare Hudson Bay with Yellowstone. Hudson Bay is a frigid basin defined by a mass deficit. Yellowstone is a volcanic plateau powered by a rising plume of hot mantle. Seismic tomography shows a cold, sinking slab beneath Hudson Bay, a downwelling current dragging the crust downward. Physics demands balance. Material that sinks in one place must rise elsewhere. At Yellowstone, seismic imaging reveals a colossal plume of superheated rock rising from deep within the mantle. This upwelling powers Yellowstone's geysers and volcanism, pushing the crust upward. Here are two landscapes driven by opposing forces, a cold downwelling in the northeast, a hot upwelling in the southwest. Could they be two sides of the same coin? The idea is breathtaking, a single continent-spanning system of mantle convection linking Hudson Bay and Yellowstone. The forces that pulled down the Canadian Shield may be the same ones that fuel the supervolcano. This connection suggests that North America's geology is shaped by a deep, hidden engine. The story of Hudson Bay and Yellowstone is a tale of action and reaction, of cold and fire. And it may explain why these two distant regions are so geologically unique. The next step, connecting the dots. The theory linking Hudson Bay to Yellowstone is bold, but evidence supports it. Computer models show that a large downwelling beneath Hudson Bay can drive a corresponding upwelling beneath Yellowstone. The North American plate rides atop this giant convection cell, with Hudson Bay as the descending limb and Yellowstone as the rising one. The trail of ancient volcanic calderas across Idaho's Snake River Plain points back toward the northeast, consistent with this mantle flow. While the connection isn't absolute, the alignment is striking. This grand narrative links one of the planet's largest gravity lows with one of its most dangerous supervolcanoes. To understand Yellowstone's threat, we may need to look far beyond its immediate surroundings. The whispering giant of the north could hold the key to the sleeping beast in the west. Science is still testing this theory, but the implications are profound. The forces at play are written across the face of the continent itself. If the Hudson Bay-Yellowstone connection is real, it could mean Yellowstone's volcanic pulse is governed by mantle dynamics 1,000 miles away. The rate of downwelling under Hudson Bay might influence the supply of heat and magma to Yellowstone. This transforms Yellowstone from an isolated system to a component in a continent-wide machine. Geologists monitor Yellowstone for immediate signs of unrest, but the Hudson Bay connection hints at a much longer, slower rhythm. Changes in mantle flow could prime the volcano for eruption, or lull it into dormancy, over thousands of years. We can't predict eruptions by watching Hudson Bay, but understanding this link is crucial for long-term forecasting. The most unsettling idea, interconnected instability. A change in the downwelling could send a pulse through the system, affecting Yellowstone's future. The silent sinking slab in the north and the fiery plume in the west may be locked in a slow, powerful dance. The fate of Yellowstone could be tied to the deep processes beneath Hudson Bay. What if the rhythm of this mantle engine changed? A sudden acceleration of downwelling at Hudson Bay could send a surge of energy through the system, increasing the flow of hot material to Yellowstone. This might trigger more uplift, earthquakes, and hydrothermal activity, potentially pushing the supervolcano toward a critical state. Conversely, a slowdown could quiet Yellowstone, reducing magma supply and volcanic threat. The two titans, Hudson Bay and Yellowstone, are locked in a geological dance, their tempo set deep in the mantle. These processes unfold over millennia, not years. There's no immediate threat, but the concept is a profound reminder. The ground beneath us is alive. Understanding these connections is the frontier of geology. It's about reading the planet's deep history and glimpsing its future. The Hudson Bay anomaly and Yellowstone supervolcano are two parts of a single, magnificent story. Our challenge is to listen, measure, and learn from the planet's slow, powerful heartbeat. The dance continues, unseen but ever present. The Hudson Bay-Yellowstone story shows the power of persistent scientific observation. From early gravity surveys to modern satellites, each discovery adds to our understanding. We must keep watching, measuring, and listening to Earth's subtle signals. Future research will refine this story, revealing even deeper connections or new mysteries. We live on a thin crust above forces of unimaginable scale. By studying anomalies like Hudson Bay, we learn about the engine that drives our world. Next time you look at a map, see a living continent, its icy shield and fiery plateau linked by hidden forces. We are the watchers, piecing together the story, listening to the heartbeat of our planet, and the adventure of discovery is only just beginning.